Explaining web work number 8, problem 21. You have to find the linearization using L of x sub y of the function f of x and y equals the square root of 266 minus 9x squared minus 16y squared at the point negative 1, 4. So to find this, you gotta know the formula for linearization, which is linearization at x sub y equals f at a and b plus the partial derivative with respect to x of a and b multiplied by x minus a plus the partial derivative with respect to y of a and b multiplied by y minus b. So in this case, a and b would be at this point here. And then to solve this, the function of a and b would be square root of 266 minus 9 times a, which is negative 1 squared, minus 16 times 4 squared, plus the partial differential at x, which would be 1 over 2 radical 266 minus 9x squared minus 16y squared times the partial derivative of the inside, which would be negative 18x, and that multiplied by x minus a, which in this case would be x plus 1. And then we add that to the partial derivative of y, which would be the same 1 over 2 radical 266 minus 9x squared minus 16y squared multiplied by the partial derivative of the inside, which would be negative 32y. And we would multiply that by y minus b, which would be y minus 4. So to solve this, the equation of the inside the radical turns out to be 1. So simplify this, would be radical 1 plus 1 over 2 radical 1 times negative 18, and then we would plug in the x value in this case, which would be negative 1. And then we would do and add that to also 1 over 2 radical 1, which would multiply by negative 32 times 4. And then we would multiply that by the y minus 4 at the end. Also, I forgot the x plus 1 in here. Alright, so then we simplify all this. We get 1 plus 1/2 times 18 times x plus 1. And then we add that to 1/2 of 32 times 4 being 128, well, negative 128, times y minus 4. So then when we simplify this and switch the equation around to the correct format, we get this solution equal to 9 times x plus 1 plus negative 64 times y minus 4 plus 1. That was our solution to this problem.